Today we are going to be starting topic 8, which is multiplying fractions, but before we do that, we need to remember how to convert between improper fractions and a mixed number. So that's the first thing we're going to do. So these are the steps to take when converting from an improper fraction to a mixed number. So the first thing you do is you set up a long division problem. The numerator goes inside the house and is the dividend, and the denominator goes outside of the house and is the divisor. Then you long divide as normal. Your quotient, which is your answer, is your whole number. Your remainder is your numerator, and your denominator always stays the same. These are the steps to take when converting from a mixed number to an improper fraction. So remember, a mixed number is when you have like 3 and 1/2. It's with a whole number and a fraction. So you multiply the denominator by the whole number. Remember, we're making this C shape. And then add the numerator. So you multiply and then you add. The number you get is your numerator, and the denominator stays the same. So this should be a review from our last unit. So what we are going to start today is using models to multiply a whole number by a fraction. So we know that multiplying is the same as using repeated addition. So I know that when I say 6 times 4, it's really like saying 4 plus 4 plus 4 plus 4 plus 4 plus 4. I have 6 4s here to represent the 6 here, and I know that equals 24. We can do the same with fractions. So if I want to multiply 6 by 2/3, I could model, if this is broken up into thirds, there's 2/3 of this section shaded, 2/3 of this section shaded, 2/3 of this section shaded, and so on if I keep going. And then I would ask, how many total parts do I have shaded? 2, 4, 6, 8, 10, 12. I have 12 total parts shaded out of 3. Remember, my denominator is going to always stay the same. So this could represent this word problem. Jeremy wants to make fruit punch. He needs 2/3 cup of orange juice for each batch. Remember, each is our keyword for multiplication. How much orange juice would he need if he wants to make 6 batches? So our answer to that would be 12/3. But this is an improper fraction, or I like to call it an upside down snowman. So to change that, I would do 12/3 is equal to, set up a long division problem. My numerator goes inside the house, denominator goes outside. 3 can go into 12, 3, 6, 9, 12. Can't go into 1, so it would be 4. 3 times 4 is 12. I do not have a remainder, so this would equal 4 cups of OJ, orange juice. Okay? So we're going to do one more with a model, and then we'll do some without a model. So 3 times 2/3. Imagine if each section here is broken up into thirds, which it is. So 3 times 2/3. I'm going to shade in 2/3 of each section. 2, 4, 6 total parts that are shaded. 6, my denominator stays the same. I know 3 goes into 6 2 times. We're not going to do this one. We're going to cross that one off. 6 times 3/4. I could also use repeated addition. I could do 6 times 3/4, so I'm going to write 3/4 6 times. Now, we're adding fractions here. Notice that all of my denominators are the same, which is what we need when we add fractions. So then I just add my numerators, 3, 6, 9, 12, 15, 18. And 4 stays the same when I add fractions. This is an improper fraction, so I'm going to set up a long division question. 4, 8, 12, 16. It can go in 4 times. 4 times 4 is 16. So remember, my quotient is going to be my whole number. The remainder is my numerator. And the divisor is my denominator. Now I can simplify this. Divide by 2, and I will get 4 and 1/2 is my final answer. I can do the same thing down here. 5 times 3/4. 3/4. I'm just going to add 3/4 5 times. Denominators are the same, so I can add the numerators. 3, 6, 9, 12, 15. Denominator is 4. Improper fraction, so I'm going to long divide. 4 can go into 15. 4, 8, 12, so 3 times. I get a remainder of 3. And remember, my quotient is my whole number. Remainder is my numerator. Divisor is my denominator. So that is my final answer. Now, you might notice something here. All I'm really doing is I am multiplying the whole number by the numerator. So I'm doing 5 times 3, which equals 15. I did 6 times 3, which equals 18. So really, what you should be noticing is you don't have to do all of this repeated addition. You can just multiply the whole number by the numerator. So when you multiply a whole number by a fraction, you multiply the whole number by the numerator. Okay? So the steps to follow when multiplying a whole number by a fraction. Make the whole number a fraction by placing a number 1 under it. So if I have a question that is like 6 times 1/4, all I would do is here's my whole number, place a 1 under it. And then I'm set up to complete this problem. You multiply the numerators by each other and the denominators by each other. So I'm going to multiply 6 times 1, which is 6, and 4 times 1, which is 4. Then it says turn the improper fraction into a mixed number. Now this one I can do in my head. I know 4 can go into 6 one time, and I'll have 2 left over with my denominator of 4 still. And then I know I can simplify that to be 1 and 1/2. Please note that you may have to do some side work to solve the multiplication or the division, and that is okay. So we're going to do these two together, and then I will let you try some on your own. So the first thing I do is I put a 1 under this 13. I might rewrite it so that it's all lined up. And then I'm going to multiply my numerators together. So I'm going to go off to the side and do some side work. 13 times 2. I'll get 26. And then I'm multiplying my denominators together to get 3. Then I need to do some side work to see how many times can 3 go into 26. So I'm going to do 26 divided by 3. 3, 6, 9, 12, 15, 18, 21, 24. So it's 8. So I know this will equal 8 and 2/3 as my final answer. Okay? I will do one more with you. So I'm going to put the 70 over 1. That's my first step. I like to rewrite it so that it all lines up. Then I'm going to multiply my numerators together. I know 7 times 9 is 63, and if I just add on that 0, I'll get 630. And then 1 times 10 is 10. Okay? Now I'm going to set up my long division question. and I get 63.